Welcome to Maths Guide at Home. Our channel provides easy to follow math tutorials and explanations to help you improve your skills and understanding. Be sure to watch each video in full to not miss any important information. Let's dive in. Greetings and a warm welcome to all the curious minds out there. Today's discussion is all about the fascinating concept of equivalent fractions. We will explore how fractions that look different can actually represent the same quantity and how we can simplify and compare fractions using this idea. So buckle up and get ready for an exciting journey into the world of equivalent fractions. Before we dive into equivalent fractions, let's review some basic number concepts. Natural numbers are all positive numbers such as 1, 2, 3, 4. And so on, continuing infinitely. Whole numbers include 0 and all positive numbers, such as 0, 1, 2, 3, 4, and so on, continuing infinitely. Integers are all natural numbers, whole numbers, and negative numbers. So, integers include numbers like -3, -2, -1, 0, 1, 2, 3, and so on, continuing infinitely. Rational numbers are numbers that can be expressed as a fraction or a ratio. For example, a quarter is a fraction that can be expressed as a ratio. The numerator is the top number, and the denominator is the bottom number. It's important to note that the denominator cannot be equal to 0. When we divide 1 by 4, we get 0.25, which terminates and has a remainder of 0. This means that 0.25 is a rational number in the form of a quarter. Let's take another example to make it clearer. If we take 3 quarters and divide 3 by 4, we get 0.75. This division also terminates and has a remainder of 0. So, 0.75 is a rational number in the form of 3 quarters. An irrational number is a number that cannot be expressed as a ratio of two integers, meaning it cannot be expressed as a simple fraction with the numerator and denominator. Irrational numbers are decimal numbers that continue infinitely without repeating a pattern. For example, the square root of 2 is an irrational number. When we calculate the decimal representation of 2, we get 1.414 to 1356. And the decimals continue infinitely without repeating a pattern. Another example of an irrational number is pi. Pi is the ratio of the circumference of a circle to its diameter and is approximately 3.14159 to 65359. And the decimals continue infinitely without repeating a pattern. It's important to note that irrational numbers cannot be written as fractions, but they can be approximated as decimals. However, the decimal approximation of an irrational number is always an approximation, and it never represents the exact value of the number. Let us summarize what we have learned so far. Natural numbers are a type of number that includes all positive integers. They do not include 0, negative numbers, fractions, or decimals. Example 1, 2, 3, 4, 5. Whole number, part of the number system which includes all the positive integers from 0 to infinity. They do not include any fractions or decimal places. Example 0, 1, 2, 3, 4. Integers are whole numbers, including both positive and negative numbers, as well as 0. They do not include any fractions or decimal places. Example 5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5. Rational fraction. Rational numbers are numbers that can be expressed as a ratio of two integers, where the denominator is not zero. They can be positive, negative, or zero, and they can be represented as fractions, decimals, or mixed numbers. Example: 2, 3, 5, 0, 3.25, 7, 2, 1.6. Irrational fraction. Irrational numbers are numbers that cannot be expressed as a ratio of two integers and are non-repeating and non-terminating decimals, which means they go on forever without repeating a pattern. Example: 2 pi e, Euler's number, phi, the golden ratio, 5. In mathematics, we often come across different forms of numbers that have the same value. These are known as equivalent numbers. Let's take an example of equivalent rational numbers to understand this concept. Consider a rectangle box that is divided into 6 equal parts, out of which 4 parts are colored in blue, and 2 parts have no color. We can represent the fraction of the blue-colored parts as 4 by 6. Now, if we further divide each part into 2 equal parts, we will have 8 parts of blue color out of a total of 12 parts. We can represent this fraction as 8 by 12. Notice that both fractions have the same value, but they are expressed in different forms. This is the essence of equivalent rational numbers. They have the same value but are expressed differently. We can also understand this concept algebraically. For example, to convert 4 by 6 to an equivalent rational number in the form of 8 by 12, we can multiply both the numerator and denominator of 4 by 2. We get 8 by 12, which is an equivalent rational fraction. In summary, equivalent rational numbers are numbers that have the same value, but are expressed in different forms. This concept is important in various mathematical operations and helps us simplify and manipulate fractions effectively. To understand equivalent rational numbers practically, let's take some examples. Consider the fraction 2 by 4. We can find its equivalent rational number by multiplying both the numerator and denominator by the same number, say 2. This gives us 4 by 8, which is an equivalent rational number. Similarly, let's consider the fraction 5 by 3. To find its equivalent rational number, we can multiply both the numerator and denominator by the same number, say 3. This gives us 15 by 9, which is an equivalent rational number. Let's take another example of the fraction 7 by 6. To find its equivalent rational number, we can multiply both the numerator and denominator by the same number, say 4. This gives us 28 by 24, which is an equivalent rational number. In summary, we can find the equivalent rational number of a given fraction by multiplying both the numerator and denominator by the same number. This allows us to represent the same value of the fraction in a different form. Equivalent rational numbers are useful in simplifying fractions and performing mathematical operations involving fractions. You provide 4 equivalent fractions for each of the following: 2 7, 5 thirds, and 5 8. To find equivalent fractions of -2 by 7, we need to multiply both the numerator and denominator by the same non-zero integer. This does not change the value of the fraction, but it gives us a different way of writing it. In the first step, we multiply the numerator and denominator of minus 2 by 7 by 2, which gives us a new fraction, minus 4 by 14. This fraction has a negative numerator and a denominator of 14. In the second step, we multiply the numerator and denominator of minus 2 by 7 by 3, which gives us another new fraction, minus 6 by 21. This fraction also has a negative numerator and a denominator of 21. We can continue this process by multiplying the numerator and denominator of minus 2 by 7 by 4 to get minus 8 by 28 and by 5 to get minus 10 by 35. Each new fraction has a negative numerator and a different denominator. It is important to note that there are infinitely many equivalent fractions of a given fraction, since we can multiply by any non-zero integer. However, finding several equivalent fractions can help us simplify or compare fractions more easily. To find equivalent fractions of 5 by 3, we need to multiply both the numerator and denominator by the same non-zero integer. This does not change the value of the fraction, but it gives us a different way of writing it. In the first step, we multiply the numerator and denominator of 5 by 3 by 2, which gives us a new fraction, 10 by 6. In the second step, we multiply the numerator and denominator of 5 by 3 by 3, which gives us another new fraction, 15 by 9. We can continue this process by multiplying the numerator and denominator of 5 by 3 by 4 to get 20 by 12 and by 5 to get 25 by 15. It is important to note that there are infinitely many equivalent fractions of a given fraction, since we can multiply by any non-zero integer. Find equivalent fractions of 5 by minus 8. We need to multiply both the numerator and denominator by the same non-zero integer. This does not change the value of the fraction, but it gives us a different way of writing it. In the first step, we multiply the numerator and denominator of 5 by minus 8 by 2, which gives us a new fraction, 10 by minus 16. This fraction has a positive numerator and a negative denominator. In the second step, we can multiply the numerator and denominator of 5 by minus 8 by 3 to get another new fraction, 15 by minus 24. Again, this fraction has a positive numerator and a negative denominator. We can continue this process by multiplying the numerator and denominator of 5 by minus 8 by any other non-zero integer, such as 4 or 5, to get more equivalent fractions. It is important to note that while the sign of the fraction may change when we multiply by a negative integer, the value of the fraction remains the same. Equivalent. With this, we conclude today's session. We hope that the explanations provided were helpful and improved your understanding of the math concepts covered. If you have any further queries or math-related issues, please leave a comment below, and we will do our best to address them in future videos. Don't forget to like and subscribe to our channel for more informative math tutorials. Thank you for watching, and we look forward to seeing you in the next session.